Hello students, welcome back to the classroom point. In our previous class, we have discussed the Nernst equation and how to use the Nernst equation to calculate the equilibrium constant as well as to find out the relationship between the Gibbs free energy as well as the equilibrium constant values. Now, in today's class, we are going to discuss how the electrode potential EMF of the hydrogen electrode changes by the concentration of the H plus ion. So let's begin the class now. EMF of hydrogen electrode at different H plus ion concentration. So let us take the standard hydrogen electrode representation and its reaction. The reduction reaction for the hydrogen electrode is 2 H plus ions in aqueous form by taking the 2 moles of electrons produces hydrogen gas. The gas of the hydrogen pressure, let us consider at the 1 atmospheric pressure. Now apply the Nernst equation for this reduction reaction, and remember that for hydrogen electrode E0 value is equals to 0. So that for standard hydrogen electrode E0 cell is equals to 0.00 volts. So that E of H plus converting into the H2 is equals to, this I am taking at 298 Kelvin's temperature, so that minus 0.059 by number of moles of electrons exchanged equals to 2 into log concentration of the product by concentration of reactant. Here product is gas, that to 1 atmosphere, so partial pressure of the hydrogen by concentration of H plus ion square, because 2 moles of H plus ion is taken. Now let us substitute the values. H plus by H2 is equals to minus 0.059 by 2 into log partial pressure of the hydrogen gas is equals to 1 atmospheric pressure and the concentration of the H plus ion square. So this 2 and 2 cancel out, so that we get the E of H plus by H2 equals to minus 0.059 into log 1 upon concentration of H plus ion. Log 1 upon concentration of H plus ion means that can be taken as pH. So E H plus by H2 equals to minus 0.059 pH of the solution, or else if you want to take the different H plus ion concentrations, you can take it here. So from this it is clear that let us apply the two conditions. When concentration of H plus ion increases, then we know that pH value decreases. The value of pH gradually decreases. So when concentration of H plus ion increases, so this can be taken as log H plus ion, here positive value. So when concentration of H plus ion increases, this value also increases, so that pH value decreases. That means EMF of hydrogen electrode value gradually increases. And when concentration of H plus ion decreases, pH value increases, so that EMF of the hydrogen electrode value gradually decreases. So it is directly related to the concentration of H plus ion. When concentration of H plus ion increases, EMF increases. When concentration of H plus ion decreases, EMF value also decreases. Now let us see a question how to use this type of the problems. So given that E of H2O by H2 is equals to 0.00 volts at 298 kelvins. So they are asking us to find the partial pressure of hydrogen. So given value is at the 298 kelvins, it is a hydrogen electrode only. So now solution for hydrogen electrode, standard hydrogen electrode, E0 value equals to 0.00 volts, as well as E value also here given as 0.00 volts. Now in this case, in H2O, hydrogen is in the plus form converting into the H2. That means reduction reaction. So let us take H plus ion, taking one electron changes to the half mole of the hydrogen gas. Now let us apply the Nernst equation for this. Both E value, E0 values are 0. So I am applying now E of H plus by H2 is equals to E0 of H plus by H2. In the place of H plus, we can write down the H2 also. In H2, H plus I am taking. It is at 298 kelvins, so that minus 0.059 by only one electron is involved, and a log partial pressure power half of hydrogen divided by concentration of H plus n. These two values are 0. So I am taking 0 is equals to 0 minus 0.059 by 1 into log partial pressure power hydrogen by concentration of H plus ion. Now this value, if you send this value the other side, so it entirely becomes the 0. So we can write down that log partial pressure power half H2 by concentration of H plus is equals to 0. Now send the logarithm the other side, it becomes the antilog. Antilog 0 is equals to 1. So that we can write down that partial pressure half H2 is equals to concentration of H plus n. Now partial pressure, half value send the other side becomes the square. So here we can write down that partial pressure of the H2 is equals to concentration of H plus n square. So now at 298 kelvins for water, concentration of H plus ion is equals to 1.0 into 10 power minus 7 moles per liter, or molarity. So now apply this value here, then we'll get the partial pressure of the H2 is equals to 10 power minus 7 whole power 2. Pressure units are atmosphere, so that we'll get the partial pressure of the H2 equals to 10 power minus 14 atmospheres. So this is the way we can find out the EMF of the hydrogen electrode at the different H plus ion concentrations. I hope you understand today's class. So we shall meet in the next class. Thank you one and all.